All right, last question. I'm going to warn you just a little bit. It gets a little complicated just with the trig. If you're not familiar with substituting numbers within the unit circle. Okay. All right, so again, we're trying to write the equation of the tangent and normal line, and I give you the point at 1, comma 0. Remember, x is 1, y is 0. Again, I got x's and y's on both sides, so to find the derivative, I'm just going to use implicit, meaning take the derivative of the left side and the right side. So when I take the derivative of 4y cubed, it's just 12y squared, but don't forget to multiply by dy over dx. Plus, the derivative of 6x is just 6. Now, when I look at my final term, I hope you see a product. So since I have a product, I have to use the product rule. And then careful, my first function is negative x squared. Okay, so the derivative of my first would be negative 2x times my original second, which is sine of y, plus the derivative of sine of y is cosine of y, but don't forget it's dy over dx, times my original first. My original first is negative x squared. And then derivative of negative 4 is 0. And then derivative of 2 is 0, because the derivatives of constants are all zeros. So at this point, you're going to try to collect all the terms with dy over dx on the left and everything else on the right-hand side. So I have 12y squared dy over dx. And then here, I'm going to move this negative x squared out in front. So it's negative x squared cosine of y dy over dx. And then this 6 becomes negative because it's moving to the right side, and this negative 2x becomes positive 2x sine of y. Again, our goal is to get the derivative by itself to find the slope of the tangent line. So to get it by itself, just factor it out. And I'm left with 12y squared minus x squared cosine of y is equal to negative 6 plus 2x sine of y. Last step is to divide to get dy over dx by itself. And I actually can't simplify anything, because if I was looking to simplify, I'd look at the negative 6, the 2x, the 12, and this negative x squared, all the terms in front, and not everything is divisible by 2 because that last negative x squared right there. So that's the derivative. So now what I'm going to do is to find the slope of the tangent line, I'm going to substitute, what was my point? Negative 1, 0? No, 1, 0. 1, 0, I'm going to put 1 in for x and y for 0. So negative 6 plus 2 times 1 times sine of 0. So this is what gets a little bit complicated, just if you don't know, familiar with the unit circle. All over 12 times y squared, well that's nice because that cancels, minus 1 squared cosine of y, which is 0. All right, so let's substitute all these numbers in. First off, a lot of things are dealing with 0 right here. This is 0, and the ordered pair is 1, comma 0 here. Remember, the x coordinate is the cosine, and then the y is the sine. So I have negative 6 plus 2 times 1, and then sine of 0, sine would be the y coordinate, which is 0. So the sine of 0 is actually 0. So that actually goes away. So remember, sine of 0 is 0. So this whole part goes away because it's multiplication. So really in the numerator, we just have negative 6 all over. Well, that's 0 because that 12 times 0 squared is 0. Now I have minus 1 squared, which is 1, times cosine of 0. Well, cosine of 0 is 1. So I have negative 1 times 1. So simplify that, that's positive 6, because negative divided by negative is positive. So my slope of my tangent line is 6, so the slope of my normal line would be negative 1 over 6. Put it all together and just write the equations. So I have y minus 0. You don't really have to have the y minus 0. Totally write y equals 6 parentheses x minus 1 is the equation of my tangent line. And then if we're just going to keep with the y minus 0, the slope of my normal line, the equation of my normal line would be negative 1/6 x minus 1. All right, hopefully you feel better about these notes. Please make sure you ask Mr. Maselli. He is there to help you. We will have a review on all types of implicit differentiation tomorrow. So if you're still not understanding it, we still have more practice tomorrow. If you need an ATR pass, have Mr. Maselli write you an ATR pass today for tomorrow, and you can write as many passes as you want since I'm in the resource room, okay? All right, I will see you tomorrow.